let's take a look at some of these other ones here. Okay, so this is a geometric, in this case, a geometric growth. So an investment is growing geometrically. Okay, so it's growing by a multiplier every single year. And we want to know what the value is on the 10th year. Okay, so I want to set up my general equation here. My Tn is equal to, I'm starting with 1,000. My multiplier, well, how do I find my multiplier? If I want to find my multiplier, I need to figure out what the multiplier is between those two numbers. Okay, so what is it that I'm multiplying by to get between those two numbers? Well, I'm going to divide these two numbers to get my multiplier. My multiplier ends up being 1.08. And I should be very careful because I just have to make sure that my multiplier is the same between all the terms. Otherwise, it's not a geometric sequence. So I'm just going to double check this. So I'm going to do 1166.4 divided by 1080, and I get the same multiplier of 1.08. Okay, so I'm pretty confident that that's a geometric sequence. So here's my multiplier, my R value, or my common ratio, and I just need to know what term I need to get to. Okay, so I need, as long as I have a starting point and the growth pattern here, my growth factor, I can get to any term I want to. I can figure out any term of this sequence. So if I want to work out the 10th term now, it's going to be 1,000 times 1.08, and I'm going to use that 1.0 from 0 for 10th year. That's going to be 9 growth cycles. Okay, so there's 9 steps from the first year to the 10th year. So I'm going to end up with 10 minus 1 is 9. I need to do that on my calculator. So I'm going to 1,000 times 1.08 to the power 9. And that's going to give me about almost $2,000. So $1,999. Okay, so that is the value of this on the 10th year. And basically I'm multiplying by that growth factor 9 times. So in this case, the growth factor, the common ratio, is 1.08, and this represents an 8% increase per year. Okay, so if I'm multiplying by 1.08, that 8%, that 0.08 represents an increase above what I started with in that year. And to find my multiplier, again, in this case here, I just divided consecutive terms. So that's what I'm doing here as well. Okay, so I'm dividing consecutive terms. I could have divided, any 2 consecutive terms. We can also use this formula. So if these terms are separated by more than one step, we can still do this. Okay, and I'll justify this formula here. So I know that my Tn plus 1 is going to be A R n minus 1 plus 1, so ARN. And this is going to be ARN minus 1. So all that cancels out. I end up with 1 over R minus 1, which is just equal to R. Okay, so I can justify this formula in this way. Similarly, I can justify this formula if they're separated by a whole bunch of steps. So for example, I have, let's say, blank, blank, blank. I have, this is going to be T4. So it's going to be AR to 4 minus 1. This is going to, and let's say I have, I've got more steps in between here. So this is 5, 6, 7, and let's get A8. So T8 is 8 minus 7. So exponent is 8 minus 7. So there's my formula here. This is from up here. Right? To get my Tn formula, it's going to be the start, the common ratio, and the number of steps in between. Okay? From number of steps from 1. So there it is. So I'm going to have between, this is going to be, I'll label this T4. This is T8. The number of steps between T4 and T8, there's 4 steps. Okay, there's going to be 1, 2, 3, 4 steps. Okay, so really I have R4 in between. So to write this out, really I'm going to have AR7, so T8 over T4 is equal to AR7 over AR3, which is equal to R to the power 4, which is a difference between those terms. Okay, so if I want to know the number of steps between 4 and 8, I subtract 4 minus 8, and there gives me my steps. So this A value represents the number of steps in between our terms. Okay, that's the number of steps. And the number of steps shows up as a power because I'm increasing by multiplication. So that means I'm counting the powers. And you can see that I can justify this power 4 because I can see between T4 and T8 there's R4 in between. Okay, and so this is where my formula comes from. If I have n plus a divided by n, Tn, that means I have a steps of times r between, so that means that when I divide these out, okay, I end up with r to the power a. So this is a very important relationship to understand how I get the growth factor. Okay, and essentially how is it growing? It's growing by multiplication. And it's very similar to the arithmetic difference, which is essentially slope. Before we found differences by subtraction. Here we're finding the ratio by division. Okay, and that's where we get these words. Geometric ratios are found by division. Okay, arithmetic differences, okay, which is slope, is found by subtraction. And this is our difference formula for arithmetic sequence. But essentially this is also the slope formula because we want to know how far apart they are by subtraction, the change in y over the change in x. Okay, and that's essentially our slope. Here for geometric changes, we're looking for the change as a ratio. And that change shows up as a power, this number of steps. That A represents the number of steps. Here A represents the number of steps. So we divide to average out the number of steps. Here we're going to root because we're dealing with powers and multiplication. So we want to figure out use the number of steps as powers.